Chapter 9, final video. Let's go and get right to it. Here we go. Starting off with a caution. Recall that when we invoke a method of the math class, for example, when we invoke that method, we actually mention the class name, math.pal, right? We invoke this pal method using the class name. So a question here is, in that same way, could you invoke the getArea method of the circle class by doing the following, by typing circle, by mentioning the actual class itself, circle.getArea? Pause the video and chew on that a bit. Could you invoke that getArea method in that manner? And the answer is no. Why is the answer no? Because that getArea method is an instance method. It has to be invoked from a particular object, from a specific object, a specific instance. So here we are, we're finally at the official coverage of instance methods versus static methods. All of the methods we've seen prior to this chapter have been static methods. In fact, each of them had the keyword static inside the method signature. Here are some examples. The get letter grade, compute GPA, miles to kilometers. We've done dozens upon dozens of methods, each of them having the keyword static in the method signature. And so we can understand these methods as being owned by the class itself, belonging to the class, not belonging to a particular object. Another way of understanding them is they're really service level methods, such as that math class, that math library, where we have that PAL method and many other methods. These are just service level methods that the math library provides to you, that we can call those methods, we can send them values, and it returns to us those answers. But these methods are owned by the class itself. So in that same way, we now have methods that are intended to operate on specific instances, specific objects that we create from these blueprints, from these classes. Important to remember that the word object is a synonym for instance of a class. Those are synonyms. And these methods that operate on specific objects, they are called instance methods. These methods do not have the keyword static in front of them. They do not have the keyword static in their signature. And this indicates that these methods do not belong to the class itself. Rather, you can think of instance methods as being owned by the individual objects. Instance methods are strictly invoked by instances of a class, by objects. And instance variables also belong to a particular instance as well. They belong to a particular object. Look at this example we've seen many times. Consider the following two string objects. We have string S1 equals Java, string S2 equals OOP. How do we get the length of S1 and S2? A very easy question, right? We get the length by invoking the .length instance method from those individual objects themselves. We would say S1.length. That would give us 4. S2.length would give us 3 for OOP. We would not invoke S2.length and expect it to give us 4 for Java, because S2 is what? It's a reference to a particular instance, a particular object, which has OOP inside it as the string. So when we ask for the .length, we expect it to return to us 3. So we can think of this .length method as being owned by that individual S2 object, that object that is referenced by S2. It has its own .length method that it owns, and when we call S2.length, it will return to us 3. What if someone said, I would like to get the length of S2 by calling that .length method from the class itself, not saying S2.length, but instead someone says, but I want to ask the string blueprint. I want to ask the blueprint to give me the length. And so you type string.length. Well, that's meaningless. In fact, it doesn't make any sense at all. Here we're asking the blueprint to give us the length, and the blueprint's like, I don't know the length. The length of what object? If you want to know the length of a particular object, the blueprint's like, go ask that object, and that particular object can tell you the length. That's an instance method. Static methods they belong to the class itself. And those static methods, they are not tied to a specific object. We can also have static variables. This is going to be new for us. These are variables that have the keyword static in front of them. What's the purpose of a static variable? These variables are part of the blueprint, but they will not be connected to or tied to specific objects. Instead, a static variable is shared by all instances or all objects created from that blueprint. And finally, we can also have static constants. Now, as we know in Java, a constant is simply a variable with the keyword final in front of it. A static constant has the word final, of course, and it also has the word static, the keyword static. These constants are shared by all instances of the class. So the summary of static versus instance. Think of instance variables as belonging to the actual objects themselves or owned by the individual objects. And think of static variables as belonging to the class or owned by the blueprint, owned by the class themselves. And finally, as we've seen, to declare static variables or static constants or methods, we always use the static modifier. From a UML perspective, because we've seen UML briefly, and UML, as we've seen, the purpose of it is to simply have a visual depiction of a given class. Instead of having to spell out detailed pseudocode of what you're wanting a class to be, you can merely provide UML. This says, hey, I have a class called Circle. It has 2 data members, and here are the various constructors and methods in the third most lowest section of the UML diagram. So some new components of the UML that we'll see now is this minus and plus. The minus sign indicates private visibility, the private visibility modifier. The plus sign indicates public. And finally, underline is something new. What does an underline mean? An underline indicates that a given data member is static or a given method is static. And it would make sense if we have a data member called number of objects and it's static, we would expect its respective getter that will get those number of objects, it should be a static method as well. Now, that might be a bit confusing of why would we need, going back to this example when I said we can have static variables, why would we need, or what would be the use of a static variable? When would we want a variable to be shared by all of the objects that we create from a particular class? What's the value? When would we want that? We're going to go over a nice example right here, and then we're going to code one up using that student demo example that we've coded together already. So here we have this circle blueprint, this circle class that we've seen many times. It has a radius, which is private. We therefore have a get radius and a set radius that are also going to be public. They're getter and setters, that accessor and mutator method. And then we have this get area. Of course, it returns the area. None of this is new. The only new thing here is the idea that we have this static variable, which is also private, and it's an integer, and it's called number of objects. So what would be the standard way? If I had said write a program that's going to create many circles, many of these circle objects, and print stuff with them, do things with them, but also keep track of how many objects have been created. If we did not discuss static variables, the standard approach would be like, okay, well, in my main, I'll just make a variable called number of circles or num circles. And every time that I create a new circle by saying new circle, at that moment, I'll also, on the line afterwards, I'll increment this line of code. I'll increment this variable num circles. And you would do that in your main, and no problem. But that's not the correct OOP approach. The correct OOP approach is what you see here. We define this variable number of objects, or we could have called it num circles. It's a static variable, so it will not belong to the individual objects. Rather, it belongs to the blueprint. And so this variable, the blueprint will use it to keep track of how many circles have been created. And notice, data members, we normally never initialize them because there's no point of initializing a data member inside the blueprint. Rather, the initialization should always happen in the constructor when you're building an object, right? Well, here you notice we actually initialize this number of objects to 0. And that makes sense because since this variable number of objects is a static variable that belongs to the blueprint, you will not initialize that in a constructor when you're constructing individual objects, right? So when you construct individual objects, you won't be touching the static variables, or you certainly won't be initializing them. Instead, what we actually do is inside the constructor, when we construct the individual circle objects, and we have here 2 different constructors, inside these constructors, when we're setting radius to maybe the parameter sent over to the constructor, or even here in the default constructor with no parameters, when we just give radius a 1, inside these constructors, we increment this static variable number of objects. For what purpose? To indicate, hey, we're constructing a brand new object in main or in some other class. Someone has asked to make a new circle. Therefore, let's increment this static variable number of objects. So in main, if someone has created 12 circle objects, well, that means within these 2 constructors, we would have invoked either this line or this line, a combined total of 12 times, which means number of objects would equal 12. This is the correct use of that static variable and to count the number of objects. So here is an example as well. So we make a circle object, we print its details. Here we just change the radius and we print its details again, no harm, no foul. We make another circle object, we print its details, nothing new here. And then the most important component of this slide is at the end. The number of objects created is, and notice how we invoke this get number of objects method. So the answer is going to be 2. It's going to print 2, right? Because every time we called this new circle right here and right here, when we called new circle, what happened is we incremented number of objects, right? So now that variable number of objects has 2 inside. So here, when we print the number of objects created is, we will actually print the number 2. But pay attention to how we called this. This is a static method, get number of objects. Who does the static method belong to? It belongs to the blueprint, to the class itself. So here's where we should call the class. We should say, yo, circle class, tell me, what are the number of objects that you've made? And the class itself will tell you, oh, I've made 2 objects already. It makes no sense to type C1 right here, or C2, the variable C1 or the variable C2. You could, it would work, if you typed C1.get number of objects, C1 would be like, why are you asking me to tell you the number of objects? I mean, I can tell you, and it's going to really think of it as it's going to have to go to the blueprint, ask the blueprint, hey, what are the number of objects? You can ask C1 to do that for you, but that's not really, it's strange, right? Why ask the individual object how many objects have been created? It's like, I don't know. Go ask the blueprint. And that's what we're doing right here. Here's a visual depiction showing the UML itself, where we have radius. We have here this number of objects, and this really should have a minus sign for radius and minus sign for number of objects. This came from the textbook. They chose not to include that visibility modifier at this juncture. But here we have the static variable number of objects and the static method. We instantiated, which is created, we instantiated 2 circle objects. Each one has a different radius, but most important is this right here. The number of objects is going to be 2. All right, time to code. Let's jump back over to NetBeans and revisit this example we did last time. Which example? It's this one, where we have a student class, we have an address class, and then we have this OOP demo final that we made. So I'm going to zoom into these, pull up this exact example. So I'll remind you, we had this address class with these 5 data members. We made 2 constructors. We had all these getters and setters. That was done by NetBeans for us, made our life so easy. Notice, even in the second constructor for address, we have the 5 components of the address that we save into their respective data members. For student, let me delete this. That was something I was adding beforehand. For student, we have these 4 data members. The first 3 are an ID, a string first name, and a string last name. And the 4th data member was a reference to an address object, which if you recall, we created that address object inside the constructor. The two constructors here, we created an empty address object, and here we created an address object where we sent to that address object the 5 components required for an address object. Where did these 5 components come from? They came from the parameters that were sent over to the student constructor. So here's the example we made. We sent over 9 values to the student constructor. The first 3 values, or maybe we sent over 8 values. The first 3 values, ID and first name and last name, we saved into those respective data members. The other 5 values, we simply forwarded on to the address constructor. We had the getters and the setters. And then finally, we made this other method called print details to print the details of that particular student object. Okay, so we want to go and we want to revisit that example. That's the one we just covered. Pull it up, make sure you have everything the way you need. If you haven't finished it, go back to that previous video. Make sure you have that example working perfect. We want to edit that example now by adding a static data member to the student class. We want to add this data member, private int number of students, and we also want to make the getters and setters for this object, or for that variable, and then we want to demonstrate the use of that static data member. So let's go do that. So I'm going to come here to the student blueprint, not the address, the student blueprint, and I'm going to make a new variable. It's private, it will be static, and let's call it int num students, and here we set it equal to 0. And I'm going to put a comment. Static variable to keep track of the number of student objects made by this class. So we want to go ahead and make the getters and setters as well. So you could come down here and make them way at the bottom, which is appropriate. So we'll do that. First, I just want to make it up here and talk about it really quickly. So I'm just going to hit enter, and I'm going to right click, insert code, and let's let NetBeans do this for us. And so I'm simply going to check this, and notice it doesn't even list out the other data members because it recognizes these other 3 data members up here, or these other 4 data members. It recognizes it's already made those getters and setters. So it's not even asking you to remake them because it's already made them. So right click, insert code, getter and setter. You can just select here num students, or you could select the entire class. Either way, you're saying make all remaining getters and setters. I'm going to check encapsulate fields, which would make it private, but I've already declared it as private, and hit generate. Now when you hit generate, it goes and it puts them at the top. So we're gonna have to copy and paste them or cut them out and then put them where we want. But I wanna point out something that, first of all, I want to point out that we see the word static in front of both of them, which is important. That Java recognized this is a static variable, or NetBeans recognized it's a static variable, so therefore both of these methods were made static. So just like this variable does not belong to the individual objects, but rather it belongs to the blueprint, to the class, in that same way, any getter or setter methods that are going to access or modify that variable should also belong to the class, not to the individual object. So they should be static. Now, what I want to point out is notice this right here. This looks like the cheesy way that we showed previously, where instead of using the exact same variable name, right, this is the proper way that we've seen of doing a setter is something like this. Now that gives you an error all of a sudden. Why would that give you an error? Remember, if we come down to any setter, we want the variable name of the parameter to match the variable name of the data member. And we have to use the word this for what purpose? Because if we get rid of the word this, right now, Java's like, well, I can save first name into itself. Java examines, let me zoom in some more. Java examines this method. When you say take first name, save it to first name. Java examines this method. It only sees one usage of the variable first name, a parameter, which is now a local variable. And so it says, well, I can save it into itself if you really want me to. It's kind of weird, useless, but I can do it. But you're like, no. Save the parameter first name into the first name data member of this particular object that we're trying to construct, or that we're trying to set, that we're calling this set first name from. Well, in that same vein, if you did that up here, do you already realize why that would be weird? We're trying to set the number of students. And so if I say, yes, Java, or yes, NetBeans, or Java, take this parameter number of students and save it into the data member num students of this object, hopefully you catch why that makes no sense. Because there is no num students belonging to this object. Num students does not belong to the object. Num students is a static variable that belongs to the class itself. Let's see what the error says. Non-static variable cannot be referenced from a static context. That may not make the most sense. Hopefully my explanation makes sense. So num students does not belong to an individual object. So you would not do that. And of course, this is confusing. And so now we can go back and we can see why Java used, or NetBeans used, the cheesy way. It really took your variable num students, it put the letter A in front of it, and put a letter A here, because it needs to be two different variables. We're saying take this parameter that we're sending over num students and set it into the static variable num students that doesn't belong to any object. I don't like that variable name though, so I'll maybe call it number of students, just to give it a more meaningful, not more meaningful, just what is a num student? So I'm going to go ahead and change that to this. And so now we have our getter and setters. I cut them out, I highlighted them, and I hit Control X. And I'm going to come paste them all the way down here at the bottom of my getters and setters. Perfect. All right, so we made our static variable num students. We made getters and setters for them. What have we not done is we initialized it to 0. Well, when are we actually going to increment num students? Every time we make a new student object. So I need to come right here inside when making a new student object. Here is where we should increment num students. Done. And let's do that in every constructor. So I'm going to highlight both of those lines. I'm going to paste that here. And I notice I did not finish that comment. So let me do that here. Here we are forwarding on the 5 address parameters to the address constructor. Cool. So now we're ready to go, and let's go test this. So I've made one student object. So let's print student dot, let's call this number of student objects created. %d new line. Let's make this a printf. And here I need to type in student dot, and notice it has this method get num students. It's a public method. It's a static method that belongs to the blueprint, and it will return us the number of students. Okay, let's run this code. We can get let me zoom out just a bit. Let me pull this up a little bit so we can see the whole thing. So it prints out the details of the student object that we created, and then it prints the number of student objects created is 1. Let's make another student. Student s2 equals new student. And I won't even set any information in that particular student. And let's now print the number of student objects that we have created. So we're asking the class, hey, now tell me how many objects have you created? And I didn't print out anything. Let's print the details. I'm not sure what this is going to print. I don't recall what we made in here. Did we put unassigned? I need to make this s2.print details. Yeah. So we didn't really make it pretty. We notice it says null, 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 because we're trying to print. I made a new student, and the ID is 0 because it defaults to 0. And we learned last time that any reference data type will have a default of null if you don't give it anything else. So if you wanted to make a new student and possibly needed to print it and didn't want null to print out, as we've seen, in this constructor, we could have initialized first name to equal maybe unassigned. And we could have done last name equals, same thing, unassigned. And we could have done that for each one of the data members. So now when I run this code, it would say ID is 0, first name is unassigned, last name is unassigned, and so on. But the point, that's not part of this topic that we're covering here. We've now created a second student. We've printed the details, and we have the number of student objects created. Let's make a third student. So here, let's highlight these 3 lines of code. And for this third student, let's send over, once again, all the necessary pieces of information. So we have to have an ID number 111, 2222. We need a first name. I'm going to look over here. Once again, not going to be super creative. Oh, I need a name. Where's a name? Grimaldi. I don't know a first name. So Bob Grimaldi from a discrete math textbook. Where does Bob live? Bob is also at the same location, somewhere Boulevard, at office, some other office, office number 102. And Bob is in Lakeland as well, Florida. And here's Bob's zip. So I made that third student, and so now number of student objects created is 3. Let me put a new line here, an extra new line, just so we can put some spacing between each one of these. All right, so I have the first object, myself, number of student objects created, only 1 at that point. We then made another object, and then we asked the blueprint, hey, tell me how many objects you've created thus far. And it tells me I've created 2. Then we create a third object, S3 is what that should say. And now we print that third object and we ask the blueprint, the number of objects created is 3. So hopefully we understand this approach. This is the correct way of keeping track of the number of objects that the blueprint has created. Again, if you didn't know that, the cheesy way would be here in main, you'd say int num students equals 0. And then every time you make a new student object, you would have come in here and you would have said num students plus plus. And that would work, right? And then you would just have to use that variable. But that's not the correct OOP way. The correct OOP way is, you already have a blueprint. That blueprint is where you should maintain how many objects have been created. And so this is the correct approach to make that happen. And the final thing I wanted to cover while we have this code open is, as mentioned, when we invoke this getNumStudents method, which is a static method belonging to the blueprint, you want to invoke it from the class itself, right? You want to use student dot. We want to ask the class, hey class, how many student objects have you created? And the answer is here 3. Now I could have said S3 dot getNumStudents, and notice that when I did that, it doesn't give me an error. It's still going to work. But look at this message. Let's see what it says. Accessing static method getNumStudents. It's really saying, hey, you're using an object to access a static method. I mean, we can, but it doesn't make sense. Like student S3, if I ask student S3 to print the details, it's like, I got you, I'll do that for you. But here when I ask S3 to go, hey, can you get the number of students? S3 is like, damn it, are you kidding me? This mother blinking developer. It doesn't realize it's wasted my time. It's supposed to be asking the class. Why is it asking me to get the number of objects? It'll do it for you, but it's not appropriate. The appropriate thing is ask the one who is in charge of that. Ask the blueprint. Ask the student class to get you those number of objects. We are making great time. We have 2 more major concepts and 1 smaller thing. Passing objects to methods. We've seen that passing by value for primitive type values, what value is actually passed as a parameter? The primitive value itself. So when we send an integer to a method, we're actually sending over that int itself. But passing by value for reference type values, what's actually passed to the parameter? Such as when we send an array, when we're sending an array to a method. What is actually sent? Because it's called pass by value. But which value is actually sent? The reference is what's being sent. The reference of that array on the heap. Or in this case, the reference of the actual object. So just like when we pass an array, what is sent? What is sent is an address of that array in memory on the heap. That's what's sent. Well, in that same way, similarly, when sending an object to a method, the address of that object is what is actually sent to the method. The value proposition in understanding that is that we can access and we can update the details of that object because that object is stored on the heap. So any changes that we make from within a method to an object, they persist outside of that method. So here is just an example. We're going to show two classes, the standard student class. We have data members, name and email. We have a constructor, some getters and setters. And here we have a library card, which has an owner. We also have a variable called borrow count that keeps track of how many books have been borrowed. We have a constructor, and then we have getters and setters, and also this method called checkout, which I see here is misspelled. This came from the publisher as well, directly from the book. So here, passing a student object. We have a lot of code showing up top, and we're going to make sense of it and to show you a visual depiction of what's going on. We have declared a student variable of type student. We've now made a new student. We save the name John Java and the email into that student by using their setters. We also make a variable called card2, which is of type library card. We make a new library card object, and we set its owner to what? To student. Well, what is student? It's an address that points to the student object. So when we call this set owner method, it's a setter method that belongs to, it's an instance method that belongs to this card2 object. When we call this method, we're going to actually send over a reference of this student object. So let's go through that. So here's the new student that has no, we have right here, it points to null. We haven't actually saved anything into it yet. Now we create the new student object, and it has these values that we've set inside it. And so student is an address that points over to this new student object. Here we have card2. Card2 now points to this library card that was just created. The borrow count is 0, and the owner is currently null. No one is the owner. So what happens next is when we call this set owner method, and I send over the address of the student, what actually happens, here's the address of student. It's sent over to this formal parameter within this set owner method. And now this formal parameter is also pointing over to that student object. And then what happens next? This is step 2. Step 2 is we save that address into this owner variable. So now owner also points over to that student object. Nothing really novel there, just the idea that we can pass over objects to methods, which really means passing the address or the reference of that object. Here's just another visual of that exact same thing. Another example here, and really this example is showing the same thing. We have here that library card, card2. I've made a new library card, and I want to now set the owner. Here's the class library card. We have a student owner, and here we have set owner, that set owner mutator method that's receiving this reference that we're saving as a formal parameter st, and this is just going to be another visual depiction of what's going on. So here in step 1, when we call this set owner method, what's happening? Because this is all about passing the student object, or we're passing an address. So that address in step 1 is sent over here and saved. It's sent from the actual parameter and saved inside this formal parameter s2. So here's what's happening. We have here two variables, student and card2. Student is pointing over to the student object. Card2 is pointing over to this library card object. This student object has already been created that we showed you on the previous slide. So now, when we do step 1 and we send over the reference saved inside this actual parameter student, and we send over that reference, that address, it's now going to get saved inside this formal parameter st, which means what? ST now also points over to that same student object. And then step 2, when we make this assignment, we say take whatever's inside ST, which is an address to the student object, and save it inside or assign it to this variable, this data member owner. So when we do that and we save whatever's inside ST into this data member owner, now owner also points to that same student object. Here's just those two classes. The student class, nothing really new here. Two data members, constructors, getters, and setters. The library card class, we have a single data member called owner, which is of type student. We also have a second data member, which is an integer called borrow count to indicate how many books have been borrowed. We have a checkout, where if you want to check out 3 books, you're basically increasing your borrow count. We have a get owner, a get number of books that's been checked out, and a set owner, as well as a toString method. This toString method is unique. We'll revisit this a bit in another video, but here this toString method, it's similar to that print details method, but instead of printing, we're going to just return a string representation, and it's going to ultimately get printed in main, a string representation of that object. So we could have printed everything here. As you see, it looks like we're almost like printing it. We're saying owner name, and we're concatenating the name, email, concatenate the email. But instead of printing it, we're actually just returning a single string, which means here in main, I can just say card2 dot, and I call that toString method, and it returns that string, which I then print in main. And we'll talk about why this is useful. So the only takeaway of this example is just to make sure you understand that when we pass an object, we're not passing an object, we're actually passing a reference to that object. And because of that, this object can therefore be shared. Here in this example, notice we have card 1 is a new library card, card 2 is a new library card, but we've set the owner of both of these library cards to student. Why is that allowed? Because student is a single student object, and of course we can set the owner of these 2 cards to be that same address to that same student object, indicating that we have one student that owns 2 library cards. One small thing and then one other big thing. This small thing here, I'm saying it's small, make sure you understand it clearly because it's going to be just 2 or 3 slides. Very important to understand what is an immutable class or an immutable object and what makes that up. We've seen this word immutable previously with strings, right? Once you make a string, you cannot change its contents. A string is an immutable object. If the contents of an object cannot be changed, once the object is created, the object is called an immutable object, and the class from which it is created is called an immutable class. A class with all private data fields, and imagine now if you make no mutators, no setters for that class, you might think, oh, well, if everything's private and there's no mutators, it has to be immutable since we can't change anything. But it's not necessarily immutable. Why? Because it could be that this class in question, maybe it has an accessor method that accesses an object, such as an address object. So imagine if you have a student class, the one we just defined here in NetBeans. Let's go to NetBeans. And imagine this student class, imagine we get rid of all of the mutators. So we don't let all of the setters, we get rid of the set ID, the set name, the set last name, even the set address. You might think, well, geez, well then we would never be able to update this student object. Well, not completely correct, because since we have since we have a getter that will still get access to this address object, and because that address object itself has mutator methods, we're still able to ultimately change part of this student, a component of the address object. So if this object in turn can be changed either directly or indirectly via a mutator method, then the original class cannot be considered immutable. So here was an example similar to the one I just showed you in NetBeans. We have a student. It has a birth date variable, which is of type birth date. Here's the birth date class. These are both private. There are no setters for set ID or set birth date. So you might say, oh, Well, this is going to be an immutable class. Student is immutable because once it's made, we can't change anything. You can't change the ID. There's no setter and it's private. And you might think you can't change the birth date. Well, you can, because since we have a getter for birth date, here in main, I can make a new student, I could get the birth date, and then I could set the year of that birth date, which means birth date is mutable, and therefore student is mutable as well. So in summary, if the contents of an object cannot be changed, once the object is created, the object is called immutable, and the class is immutable. But in order for a class to be truly immutable, all of the data fields have to be private. You cannot have any mutator methods, and you cannot have an accessor method that would return a reference to a mutable object. I'm looking at the time. We have 4 minutes. I probably need about 6, but we'll see. Final thing is an array of objects, or better, more clearly stated, an array of object references. In Java, we can make an array of primitives. We've seen that. We can even declare an array of objects. We've seen an array of strings. That's really an array of objects. But in fact, it's called an array of object references because every index of this array really points to a string object. We can also make an array of students, an array of student references. So an array of primitives we've seen is very powerful. It lets you do so many cool things with your program. An array of object references is even more powerful. So here we have this sample class person. Person has name, age, gender. Here's some constructors, getters, and setters, pretty straightforward. And here is a test program. We're not making any array on this particular page. We've made a new person object, set the name to Nicolette, the age to 20, the gender to F, and we've printed their information. So with that class, I want to show you how we can make an array of objects or object references. So once again, here's that same example. We can make a person, we can set their information, and then we can print their information. What is going to be an array of object references? Here's the code. Notice the first line. I'm declaring just a single variable, PPL. What is that variable for people? It is an array of persons, but we haven't actually created the array. We've merely declared the variable. What does this variable people have? Null is what's currently saved inside of it. What's the next line of code? Now I'm saying, let's create a new array of person references of size 20, but we haven't created objects yet. This is the important nuance I'm stressing here. No objects have been created. I've created an array of size 20 of person references, but currently each of those references point to null. We've not created an actual object. We do see the keyword new. This is to make a new array of person references, but each of these individual references at 0, index 1, index 2, and so on, each of them currently point to null. But now check this out. Now I say save at index 0 a new person. Well, look what happens. We make a new person object and we save the address of that new person object into index 0. That's worth repeating. I'm going to back up. Here in this example, on this line, we've created a new array of size 20. No objects have been created. We have an array of person references is the word. We've made an array of person references of size 20, and every reference points to null. Here, we've made a new object person, and we've saved it into index 0. I can make another object of person and save it into index 1, index 2, and so on. Final slide. Let's go. What is this slide simply depicting? I've made this array of person references of size 20. I saved that address of that array into people, PPL, and I've made 3 individual person objects. Here I make a new person object. I save it to index 0. And now look at how I reference that person object. I say people at index 0 dot set name Nicolette. People at index 0 dot set age 20. People at index 0 dot set gender F. I make a new person and I save it to index 1. People at index 1, set name Riley, set age 24, set gender NB. People at index 2, make a new person, set their age to Isaac, to age 22, to male. We are at 45 minutes, which is a great stopping point. I'm just going to update this right here. So instead of now making, I'm going to come back to our main, and I'm going to say student array called students equals new student, let's just say of size 10. What have I created? An array of student references, but each reference points to nothing. So now I could have said, make this new student right here and save it at students at index 0. I've made the new student, and instead of saving it to S1, I saved it to index 0. And then I can say students at index 0 dot print details. I can do the same thing here for this student, save it to index 1. This student, I'll print details from that index 1. And then finally here, student S3, I'll save it index 2. So I won't print details from X3, I'll print details from students at index 2 dot print details. Hopefully that makes sense. So now we have an array of students, and it's okay to say an array of students as long as we know in our heart of hearts, it's really an array of student references where each reference at the beginning points to null, but now after what I've done here, index 0 points to this student, index 1 points to this student, index 2 of the students array points to this student, and then index 3, 4, 5, 6, 7, 8, 9, they all point to null. If I run this code, we get the exact same output, but now we're saving all of these student objects into an array. That is super cool. But what is more cool is what? That we are done. Let's go. We've taken care of objects and classes. We have covered a lot of information, and you are now empowered to create blueprints, to understand getters and setters, understand visibility, make an array of these objects, an array of object references. Super cool. As always, reach out if you need anything, leave a comment. It's been fun. Take care.